All right, let's talk about one of the biggest headaches in AI development right now. How do you actually know if the changes you're making to your LLM app are making it better? Today, we're going to look at how we can take a classic, data-driven method and use it to bring some much-needed guardrails to the wild, wonderful, and yeah, kind of unpredictable world of large language models.
You know the feeling, right? You've spent hours, maybe days, tweaking a prompt. You run a few examples, and yeah, it feels smarter. It feels more on point. But is that feeling really enough to ship it? How do you move past just your gut instinct and actually prove it's an improvement, especially when the model can give you a slightly different answer every single time?
And that, right there, is the heart of the whole problem. This comparison lays it out perfectly. With old-school code, everything is deterministic. 2 plus 2 will always be 4. You can write a test for it, and it will pass 1,000,000 times in a row. But LLMs, they're non-deterministic. The same exact input can lead to different outputs. And that means our entire way of thinking about testing has to change.
See, relying on that gut feel isn't just a little inefficient, it's risky. When you're building real applications that people are depending on, you can't just cross your fingers and hope for the best. Intuition is great for creativity, but for quality, we need something more rigorous. We need a system.
This really gets to the core of it. Our old toolkit is just incomplete for this new world. I mean, sure, a unit test can tell you if your code successfully called the LLM's API, but it can't tell you a thing about the quality of the response. It has no idea if the answer was factually accurate, if it was relevant, or if it was just a complete hallucination.
And this quote, "This is the paradigm shift. This is the new mindset. We have to stop thinking only about whether our code ran correctly and start focusing on evaluating the performance of the task. The question is no longer, did the function execute, but did the app actually do what the user wanted and do it well?"
So if our old tests aren't enough, what do? Well, the good news is we don't have to invent something from scratch. We can actually look back and adapt a classic, battle-tested method from software engineering that's all about making decisions with data.
And that method is A/B testing. At its heart, it's a beautifully simple idea. You have a theory, a hypothesis, that a change will make things better. So you create two versions. A is your control, the way things are now, and B is your new idea. You show them to your users in a controlled way, you measure the results, and you see which one performs better. It's basically the scientific method, but for software.
The classic process breaks down into these 3 pretty clear steps. First, you design the experiment. What exactly are you testing, and how will you know if you've won? Then, you execute it. You put it out there and start collecting data. And finally, you evaluate. You crunch the numbers to see if your idea really was an improvement and declare a winner.
Okay, so here's the magic. This is where we connect the dots. We're going to take that classic, reliable, A/B testing framework and plug it right into the modern AI development workflow.
And this is where it gets really powerful. Instead of just being a manual thing you do every once in a while, we turn these tests into structured, automated LLM experiments. And these experiments become a standard check, a quality gate inside your CI/CD pipeline that runs every single time you want to make a change.
This slide right here, this is the Rosetta Stone for this whole idea. It shows you exactly how everything maps over. Your variant isn't a button color anymore. Now it's a new prompt, a change to your retrieval strategy, or maybe a whole new model. Your metric isn't just click-through rate, it's stuff like the percentage of hallucinations or a relevant score. And this is crucial for pre-production testing. Your population isn't live users. It's a carefully curated set of examples called a golden data set. And this golden data set, this is the absolute secret sauce. Think of it as your ultimate source of truth. It's a collection of high-quality examples, the tricky edge cases, the most important scenarios that you've handcrafted to serve as your benchmark. A great way to start building one, by the way, is just to log the times your app fails in production. By running your A and B versions against this consistent data set, you get objective, repeatable results before a single user ever sees your change.
So you put in the work to set all this up. What's the big payoff? Well, it's about so much more than just writing slightly better prompts. It actually leads to a fundamentally better, more mature way of building with AI. We call it eval-driven development. What this process does is create this amazing feedback loop. Evolve-driven development means every single change you propose gets automatically validated against your golden data set. This offline evaluation acts as a quality gate right in your development pipeline, making sure that only proven improvements actually make it out the door.
And here is what that looks like. It's no longer a debate about which prompt feels better. The data just tells you. In this case, prompt B gives us a factual accuracy of 94%, way up from 85. That's not a guess, that's not an opinion, that's a measurable win you can ship with confidence. So when you boil it all down, what this gives you is a safety net. It helps you avoid regressions. That's when a change accidentally makes something else worse, which happens all the time with LLMs. It lets you objectively prove that your new idea is better, which means you can make confident, data-driven decisions. And ultimately, it helps you build AI applications that are just more stable, more reliable, and frankly, more trustworthy for your users.
Which brings us right back to this core idea. If you take away just one thing today, let it be this. Don't think of these evaluations as some extra chore. They are the essential testing practice for this new era of AI. They really are your new unit tests. They are the guardrails that let you innovate safely and quickly.
So the question I'll leave you with is this. As you're building your next LLM feature, are you going to keep relying on guesswork and just hope for the best? Are you ready to build a process to test and prove your improvements? Ultimately, the choice is between guessing and testing. Thanks for joining me today.